thing. So I like to keep my test runner running continuously on my code, so that as I have new questions or I get tripped up on something and find an edge case, I can add a case to it and make sure that I'm handling it properly, instead of like hunting and pecking and trying to just squint at the code real hard until it works. Okay. This only isn't in scope. I gotta import idle parsec to test the parser. So let's do that. Text. Yeah. Window. I like to do this sometimes in Emacs, but you miss out on coloring, which might be nice for the stream. Okay, cool. So we did get an error. That's fine. Oh, we got an error. Yeah. Okay. Interesting. So I'm gonna leave it. I'm gonna take up to there. Yeah. Now I can do my stack test fast. Fast watch. Really have like a script to do this. TA. We have to escape the inner quotes there because they're needed. It's kind of annoying about doing this way. But there we go. Okay, not enough input. Let's see. Let's just fix our parser now. Bag parser. Excuse me. Maybe we could do many till. Instead of taking the... I think it just takes the parser like that. Does that do it? I think that might. Well, maybe not. I am wrong. It's leaving the space on the end. We could strip parse text. I think that has function for that. Okay, cool. Yeah, that's good. That's what I expected. The failure I expected when I messed up the test on purpose there. Okay, cool. Bright olive. Green. So the next thing we need to do after parsing a bag, let's look at our input again. We could parse this list out. So that would be a combination, like combining the decimal parser with our bag parser, separating on a line there. And that will kind of correspond to the tuple in our contains type, the count and bag. Count bag P. Doesn't have to be beautiful. So it's going to return a tuple of int and bag. It's a nice small piece we can parse. So let's leave that undefined. We'll add a quick test for that parser. At least compile. We'll add a test for it. Just to be delicious. Just to let us know we got it right. Bag with count. Let's take an example. should probably have a little example for the... We have a plural case, a non-plural case as well, perhaps. So we might hit that at some point. So let's do that. That's only with our count. Bag P. Input. That should be 5 dotted light. Excellent. One failure. That's what I want to see. Undefined. Excellent. Yes, yes. While I'm in this buffer, let's just make sure we have that. And a singular bag. Just for sanity's sake. These parsing, I find writing the parsers these ways, especially if you're not like super familiar with what's going on, can be a little bit tricky, so it's good to try and get some edge cases in your tests up front. Okay, still one failure, so the other one works. Okay, let's implement count bag P then. That's going to be count, obviously. We use just decimal. We skip a white space. Skip as many white spaces as we want. I think there's a function for that. Skip spaces. Okay. Whatever. You can write it this way too. Skip the white space. We do our bag, which will just be bag P. This is what I love about parser combinators. Making a pretty straightforward parser out of smaller bits by combination. That's pretty much it. And then we can just return C and bag P. The type system disagrees with us at the moment. That's probably because... Here's why. Expected text. That's a strange type error. Oh, dirt. Yeah. The parser in the tuple there. I meant to put the value. Okay, cool. So that kind of works. There's one other, there's like a parse one bag probably. So a singular bag. They do the same thing we did here, just in case. And it should be exactly the same because we've proven that parse bag P works for the plural case. And the singular should work as well. We could like even do some other validation, like if it's not plural, it should only have one as the number. I don't think we need to be that pedantic. So we can get the bag count now, which is good. And now we need a list to parse the whole list of these. So the list is one or more of these separated by a comma and space, terminated with this space character, so we want to consume that, go to that as well. What do we call the type again? Tag contains. So parser for contains P. And this one, it's going to be probably just these. We might not even need to do notation for this one. Might just be able to do many with count bag. No, set by, sorry. Oh, we're gonna have an edge. We're gonna have an edge case here, just because the empty list case for contains, which I think we should be able to handle with the alternative branch. Yeah, so we want this one. This set by takes. I think it's a parser in that position. Yeah, parser. So that'll be string that, and takes it up till we do a little bar period. I don't think we're quite right, but we'll see this one. Oh, sorry, that's supposed to be a car, not a text. I think setby also does the same thing. Text or actual text. Oh, see, I did it again. I forgot the test, but that's okay. Get to it in a second. Oh, okay. This might be a false positive type thing. Because contains is supposed to be a list of these. Yeah, that should be right. I think I might be missing set by. Text. Set by. Yeah, I should take a parser there. Let's just do car. Let's try that. Oh, you know what? Set by even works nicer when you do it in line anyway. Precedence thing. I'm totally off the mark. Somebody thinks that's a string. Okay, let's just add a test for it. List. All right, input will be again from our day 7 file. Okay, there we go. Let's just put our expected here. So 5 dotted white and 2 wavy lavenders. That's what we want to get out. We parse only contains P. One input. Could be expected. Ooh, it already works. That's kind of a somewhat terrifying thing, because that can be a false positive if you're doing development this way by using tests. That's a good sign, though. It's probably right. I'm gonna let it slide. The next case we need to handle with this is a empty contains list, which has a different string representation in our data set, right? That would be the no other bags string. And so if we parse this one, that parser, it's going to fail, because we haven't implemented that yet, but that's a good thing. So that should be the right empty list. Right, we get a left failed reading to satisfy. All good. So let's do that. Now the thing with parsing this and branches is that if we put this whole parser here first in our parser and then alternate, okay, if this doesn't work, then try no other bags. This is a pretty complicated parser to go through first, whereas we just try matching no other bags first, and if that fails, we can backtrack and try this more complicated parser. That'll probably be better for us. So I'm just gonna think this one will work here, and then we'll put our alternative. Fix the type errors. All right, this one needs, so if this is a type error because if string matches, it returns a text. And if this one matches, it returns a list of tuples. And when you're trying these alternate branches, they have to be the same type. So what we can do here is we can just throw away the results and return pure list, I think. Yeah, that seems to be happy. There we go. Booyah. First try. Second try, but pretty good. Not too hard. Okay, so we can do the contains list now. Now we can parse, I think, a whole line. Oh, hi. How's it going? Yeah, you're welcome. And thanks for coming by and watching. Night ago, I think. So, yeah, Night ago was just talking about this cool Haskell library. They just had a release, I guess. Announcement on Reddit, the Haskell Reddit. Library. So you should check it out. If you need to do password validation for whatever reason, they just had a new update. I had a little bit of feedback there. I see it's really late. Well, thanks for being up so late and sticking around. I don't know what you're doing up that late, but wow. Props. I do have like 2 kids, so I don't stay up that late these days very often. But yeah, so if you're ever interested in helping out with Haskell libraries, just get in there. Be positive. Get in there. You know, you have lots to offer, I'm sure, to any project you come across. And if this is something I'm a little bit passionate about, I would say, for weird reasons that I can't really explain. But you know, I really champion this set of documentation from the NIST, recommendation 863B, the 63 series on authentication, credentials, and authentication lifecycle management, stuff like that. It's pretty important to know about these days. So get some sleep, Nightico, and I'll see you some other time. You can always catch my stream, by the way. I do post them onto YouTube. J. Kenneth King. Here. Yeah. User J. Kenneth King. So if you ever want to catch up like in regular hours, you should go there. But thanks for stopping by again. It's appreciated. So yeah, totally check out this this library. I just added a quick little PR that had a link to that in the documentation, and hopefully I'll help improve the library there. Wow, thanks for the sub. That would be great and much appreciated. Yeah, so while I'm on the subject anyway, passwords. You see this a lot in many websites. They require an increasingly Byzantine labyrinth of checks that you need to do if you end up having to implement stuff like that for reasons. This is looks like a pretty good library that will really make your job pretty easy. However, this NIST guideline 863B has it's a really thoroughly researched paper put together by a lot of collaborators, and the general gist of it is that you don't need to put characters on passwords and character limits and stuff like that. It turns out that usability is really important when it comes to managing the use of memorized secrets. And analysis has shown that it doesn't really help. So this PR kind of just sets the defaults for the library to the NIST guidelines, and the idea is that, you know, spread the love, spread the knowledge, check out the NIST guidelines. They are just guidelines, so it's not like it's gospel or something you have to follow this, but yeah, the more you know, right? Oh no! I lost it, maybe. Yeah. There, paste it in channel. There. And then be gone. And go to sleep. I like you. Okay? You need sleep. That's the most important thing when you're a programmer. Okay. Cool. Yeah. So tests, they help. Types help. Sleep is the most important thing, though, in terms of productivity and writing good code. Yeah. Anyway, so super duper library. Go check it out. See if it's something you need. Cool. So back to the problem now. We got our parser, the contains list. Now we need to parse a line. That's going to be, well, I'll put a little type of that as well. This is going to be kind of a long one. That's basically going to be a tuple of text, or a bag, and what it contains. Yeah, so actually, I don't have to write that down again. It's going to look like that. Just like our text line. I don't know if there's a better name. So if you have a better name, chat, let me know. Totally down for that. Okay, and then we need a parser for that. Let's see. Pull up example. Day 7. Let's take this one. Let's create a test from it. We can parse a bag node. Sure. Let's put it in quotes. Okay, let's write out our expected type this time, the same as we had last time. We parsed the non-empty contains list. So this one will have pale lavender. And list with 3 bright lavender. I always want to spell lavender with an AR. I don't know why. Weird. And 5 wavy blues. Gotta have those wavy blues. They're totally in season right now. So hot. And when we parse bag node key input, we should be right with our expected. That probably won't even type parser now. Right, bag node key. Bang. Okay, so now we have most of the parts we need for this. Okay, 1 failure, that's good. So let's get the bag right off the bat. That's going to be the first part of our line. Just as before, bag P. We're going to match and skip over this whole schmidt. That's a new word, I just invented it. You heard it here first. That's always contained, is it? Yeah, very cool. Always contained, so that's going to be nice and easy. So we could just match that there and pass over it. And then we can get our contains list. And oh, we got to match on the period at the end of them. Oh, we do that at the contains list, don't we? So let's match on. I don't know if it take them. The new line up. Yep, that should be fine. Yeah, that should be good. Green, love it. The other nice thing, you know, some people find test-driven development contentious. And the other nice thing I like about it is I get the short feedback loop from the type system, the type checker. Love that. You get another little dopamine hit when you get a green test too. They're not always useful, but they can be sometimes. For problems like this, they've been pretty useful this week. Okay, so we can parse a bag node. Now we just need to parse the whole file. Select all of our bag nodes. Your list. I've been kind of colloquially calling this parse input. We'll just take the text and then return our either type of the error. My typing is getting worse. Ring and bag nodes. Yeah. So let's just do a quick little one for that one. Should be pretty straightforward. Bags contain 0. Bag contain bags. All plural contain. So no edge cases stuff there, hopefully. Looks good. I'll just move. Okay, cool. So let's just use this one. And maybe an empty list one. Put a new line on it. And check. Expected. There should be a list of these. So the first one will be bright olive. I think we parsed before, so let's see if we can just grab that. We didn't. We did pale lavender last time. Okay, whatever. Typing it out by hand. Bright olive contains 5 dotted whites, 3 French hens, 2 turtle doves, and Simon P. Jones in a pear tree. Merry Christmas. Wavy lavender. That was weird. Sorry. Okay, and then I'm just gonna format this a little nicer. My second example is shiny purple, and that should be the empty list. Okay. Parse only. Or we don't even need parse only now. We can just parse input on input, and that should be right about expected. Oh, sorry, I expect. Okay, cool. So parsing the input now is a matter of only on our parser, which can be many no set by. Bag node B. Set by. New line. Like that. Okay, time to the solution. Import, Advent, year 2020, day 7. Parse. And bag as well. So let's just make sure that we actually parsing the whole thing. We'll also need data.text. .io. T. That should be qualified. And our input. B.read file. 2020. Day 7. Text. Moment of truth. Does test-driven development actually work? We'll see. Here's input. Our input. And if we get an error, maybe print it out. It won't be very useful because then, again, like out of parsec error messages are not great. What would we sacrifice for error messages? We gain speed. What we sacrifice for convenience? We gain speed. And then bag notes is what we get. Let's just print those out. We can even do a little. Yeah. One thing I did notice that sometimes happens is my parser doesn't parse the entire input file. So I'm just gonna import advent.input temporarily as a sanity check. And read input from here. And just make sure that all the nodes I've parsed, like there should be one per line. So let's just make sure that that's true. Bag nodes, length of bag nodes is equal to length of lines. So just to make sure we're consuming all of the input. And if this is good, then it's true. Okay, so we're probably parsing all of the inputs. Let me back out of that quickly. And this probably won't type check anymore. And let's just take a look at what they look like. A whole bunch of them. All right. This is what we need. So we've got our data now. The next step to this problem, then, is to build up our graph. Source code. But we're not gonna, I don't think we really need to build up like an actual data type graph. Containers has a graph data structure, if I recall correctly. But I don't really know how to use it. I'm not even sure if it's the kind of graph that we need. An adjacency list representation of a finite directed graph. Oh, it is. Okay. This could be interesting to play around with. How do we use it? Because the way I was going to go about this is just use plain old hash map. Which is kind of like a straightforward-ish way of doing it. But let's see if this can... This might already like do it for us. Who knows? So we get the list of vertices in the graph. We can get the edges. If you haven't, again, for the uninitiated, if you haven't done graphs before, that's a really big font size and not what I was going for. We would graphically would call this a vertex or a node. Either is fine. This would be an edge. And this would be the vertex. And basically, edges can be directed, undirected, or unidirectional, basically. Which I think is the same as undirected, if I'm not mistaken. Right. So that's those. So that gives us the list, the set of vertices, the set of edges, so you can kind of represent them both. And that's what an adjacency list. Our data structure that we're parsing actually kind of looks like an adjacency list. That you can kind of see, I think. Yeah, like, sort of. Yeah, this is kind of what I would expect. So yeah, you give these list of your nodes. I guess it's got two types here, node and key. It's an order constraint on key. And then it returns to you the graph, a function for getting a vertex out of the graph. Or no, getting a node out of the graph from a vertex. And a key to maybe find a vertex. Yeah. Oh yeah, there's node from vertex, vertex from keys. Kind of. Okay. So that's the gist of constructing one of these things. And then I guess that lets you... Oh, I think node is just how you kind of label these things. Otherwise, why would you give these functions back? Let's look at some examples. Oh, that's why. Okay, yeah. So it does... When it constructs a graph, it encodes it in an array, which is a way you can represent adjacency lists, but it uses integers, I guess, to be efficient. So in order to get, like, the human readable label back out, you kind of got to tie it to something. Cool. Does it have an easy way for us to... What can we do with it? Transpose it, that's fine. We're not really interested in the properties. These are all different algorithms, or graph algorithms on it. DFS. Spanning forest, the part of the graph reachable from the listed vertices. Obtained from a depth-first search of the graph, starting each of the list vertices in order. Oh, cool. Cool. Okay. So that can do a depth-first search for you. That's nice. And then you get back a forest, which is really... I think that's probably... Yeah, just a list of trees. So one tree for each vertex you give it, I guess. There's probably like a dependency between the size of that and the output. One depth first search for each. Don't really care about topological sort. By components. Returns the list of vertices reachable from a given vertex. Okay, let's take a look at that, if that's kind of, if we can use that. These examples are pretty hard to read because it's all in the encoded form. That's kind of annoying. I think this one is supposed to look like 0 to 1, and from 1 to 2. And if you give it 0, I guess it includes itself in the output, looks like. I guess it just goes out to degree 1, so it just finds the... If 2 had more connected elements here, probably only gives you this set here. I think that's probably what reachable means. These were like... Sorry. This is supposed to be a directed graph. That's interesting. 0. Well, I guess 0 would be in there. 0 itself to 1. And if 1... Oh no, maybe it would be all of them. So that's probably not quite what we're looking for. Yeah, that's right. I don't think we can use that exactly. Maybe we can, but I don't know. I think that's it. Looks like it's construction, conversion. Jeez. I'm not really sure what strongly connected can do for us. And I'm not sure if there's an easy way for us to do our own depth first search over this graph representation, so I think I'm gonna punt on data graph and just stick with containers. It'd be interesting to try it out sometime though. Come back to that. But yeah, cool. There's a directed graph constructor, data structure in containers. Good to know that. Okay. Back to the solution then. Let's think we have hash map. Do this the old-fashioned way. Oh, we don't have unordered containers, so let's just add that. Oh, we do have unordered containers. Unordered containers down here. Cool. So we'll need that hash map. Let's do it again. Qualify. Do that on hash map. Script. And probably gonna want sets because we're gonna get we may end up, yeah, we just want the number of bag colors that eventually contain this one. So we want really the set of bag colors that can eventually contain one shot. We don't want to count the duplicates. So if we end up in our search coming to a particular node twice. We don't want that, so we'll probably want set as well. Set. That's those are the set functions. Okay. So we have the bag nodes. That means we can build our structure. What's our data structure going to be? It's going to be a bag tree. Yes. Hash map of check a bag to contains. That might not even be a big. It would be like this. And cool, so we got to build one of these from our input list of nodes, I think. So we'll take our bag nodes and turn bag tree. And that's it. Okay, so we could do this recursively if we wanted to. We're gonna need node list. We'll probably do it on the internal function maybe. And the node list is the second one. Got empty hash list to start. Tree. So we have the empty list, and we can just return the bag tree. We've built everything. Otherwise, we have some node and a list of nodes. Okay. This is the interesting thing here. So the goal for us is we're gonna have to look if the bag is in the bag tree. If it's not, then we can insert it. So we have two cases here. So let's do that first. We do it to zero. Might be a nice way to clean this up to do it as a card of some kind. So I think there's a neat trick to do that, but I can't remember what it is off the top of my head. Let's just do it the case matching way. For now, it's pretty straightforward. So h dot lookup node in bag tree. Okay, we have nothing. We have rest. And lookup will return the value. So some bags. That's cool. There might even be like a library function in H if I'm not mistaken. For doing this kind of like upsert type operation. Let's just hack it out for now. Nothing. I want to do h.insert then. Node and the nodes to bag tree. In the other case, we want to do, I think it's update node to these combined with nodes. Okay, true. Bag node. It's just bag node, singular, to the list. Alright, issue. I'm not getting active mode there. Probably not. Yeah. The recursive case of this, of course, is not going to be or the return type, sorry, of update is not going to be hash map, isn't it? Looks like it's a maybe. Let's check that API out. Hash map. Insert. I think we got that one right. Yeah. TV, hash map, turns hash map. That one's fine. What's the other case? Let's see. So. I don't quite want that answer there. Okay, adjust seems to not have this problem. This probably might be what we want, maybe. Although, yeah, we get a function of value to value. Update the expression, updates the value x at k. Put it in the map. If f of x is nothing, the element is deleted. It's just y, k is bound to the new value. Alternate. Yeah, okay. Maybe update. Need to return a, maybe a. That's our problem. Code. We want to give that function first and then the key. We actually don't care about this here. We just want to get the existing bees and return the best bees combined with the ones we're trying to insert. Which we're shadowing the name here, so just don't worry about it. And nodes. Of course, that doesn't work. am I doing here? Okay. Maybe. I think I'm returning. Maybe. It's not quite right, is it? Is it maybe just a precedence thing? Did I mess up? That would be kind of weird if it was. I guess it was. Curious why, actually kind of curious why that actually worked. But, I mean, obviously it was a type error. What was it I'm thinking I was doing? Anyway, so that should construct our hash function from our input to build up a hash map of our stuff. So if we try to create a bag tree for that, print it out. Oh, no good. Because we don't recur, of course. I'm missing that part. So I'm gonna call go again. Right, so if in the nothing case where it doesn't exist yet, we just have to insert it into the map. I think that's the way it would go, right? And fill out the rest of the node lists. In the just case, we do that again. And these as well. Let's see what that looks like. Probably pretty big. Okay, and one thing I want to kind of check out. If I do bright olive, I don't think it appears again. So we might not even hit that second K, as it looks like. Right. Yeah. So, like, we might not have two cases where we have, like, bright olive bags with two contains lists just on separate lines. So we might not even hit this second case at all. We might even just be doing this. There might be like a more efficient way to do it. But we got our bag tree now. So I guess the idea now is that we need like a search function to find our answer. What are we doing on time? We're little behind on time, so we'll try and see what we can do here in the last few minutes and see if we can get something going. So we're going to give a node name, shiny gold, I guess, as our input. Find bags, I guess. We'll give a bag tree. And maybe, oh, hint. Right, we want to find how many. Find numbags. Probably a pretty good name. What's up, B? Little B bag. Okay. How are we going to do this? Hey, Alice. How's it going? Nice to see you. Thanks for stopping by. We're just doing day 7 and trying to wrap up day 7 of the Advent of Code. So we're doing depth first search, using some dynamic programming type stuff to look in our map. And we're just about to implement the search function right now. Okay. So the first thing we need to do is we need to, for the current node that we're looking at, get out of the hash map the set of bags it contains. So get the bag out of the bag tree. So we need, that's lookup, which we just used above. So I'm not even looking that up again. What do we want to call this? We could do case match on it. B and bags. Okay, so we have 2 cases, of course. Nothing. And just the bag. So it exists. Okay, what case do we want to handle first? Let's look at, let's go with just this one, the just case. So if we look up into the bag and we find something, oh, actually this might not be B prime, this will be the value, I think, right? So this will be B's. That's the set of bags that this bag actually contains. So this probably be, let's just rename this up to make that a little more clear. And this will be bags. Right? Cool. Alright, so then when we have this here, we want to build up the set of I'm going to build the set of bags. Yeah, we want to build up the set of bags from the one that could contain the one we're looking for. Since we're starting, we know we're going to start at gold in the first case, the shiny gold. I don't know. Let me just draw this one up so you can see what I'm looking at. Nice. Alice. And this diagram hopefully will bring you up to speed. Cool. So this is our kind of like an adjacency list description of a graph, a directed graph. I think that's kind of what I'm going with for this puzzle. So meaning that the edges here are going to point to some node. And contains basically means that this ancestor node is a descendant of, say, this node up here. Okay, so our goal, so this parent node would contain this node down here. And our goal for this puzzle is to find the set of vertices, nodes, that can contain the one we're looking for, the one we're starting with. Does that make it clear, I hope? So, in order to do that, we're going to have bags. So make a set from that. And we'll concatenate onto that. No, not int. Let's do set of that. That makes a lot of sense. Because I want to do I want to be able to do natural. I want to construct this list on the natural recursion of find bags. We're going to map over the children, I think. So what we're going to do here is that for each bag in the set we just got out of the map in bags, so in this case it would be like this would be the only element in the set, but there could be others. We're going to basically do the same thing. Right? We're going to go to this node, this bag, and we're going to find all the ones it's connected to in that set, so on and so forth. Right, we're going to make a set from that. And what else do we need from this in order to make sure? We need a way to terminate this and to get the union of everything that we eventually find. And we're kind of looking for nodes, all the nodes we can reach from this one. So we're just going to fan out through our directed graph, right? And maybe that one points that way. Maybe this one does point that way. That's okay. Well, this is kind of why we want the set, so that if we recur on this one, and we've already seen this one, it's fine. Because we'll collect all those nodes if we just we did this simply without the sets. But if we use a set, we compress it down to our answer, which is going to be the number of bags. I think find num bags is just going to end up being kind of a helper function because it's going to return the set of this, but we really want the length of that set. So we could probably squish this around so that this is all internalized to that function. We can recover the int, which is what we actually want for the solution. But so let's map the natural recursion of find number of bags over bags. And we'll take the union of that. Clean up my drawings. And GHC, are you telling me I have errors? Okay, yeah, that's a little better. I'm not used to just it working on the first try. Weird. Okay. Oh, we haven't fully handled all the cases yet, so what to do in the nothing case? That's kind of... We could just return the empty set. That's kind of like our zero element. We're combining these together. No harm, no foul. What is the type there? Well, I'm probably messing something up here. Well, let me just double check that I know how to use something. I don't know why my tooling is not working at the moment. Import qualified. And I think that just takes. Yeah. Actually, I think that takes. It's gotta take two, right? 2 sets. I'm only giving it 1. Yeah, so we want to union together this with... We need to give it something there. We've already used bags. We could just... I don't think we have anything else we can put in there. So I guess for that. Might not be right, but let's see in a minute if it's... Of course, this is probably not the right map that I'm looking for. Yeah, because bags, I think, is a type list. And of course, this is the kind of the disadvantage of type aliases here, not having good tooling in place at the moment. Bag. Where are we? Yeah. That is a list. That should be. Oh. Yeah, we don't want the int in there. I mean, we could just throw it in there, right? Does it really matter all that much, having extra data? Is that the problem? Let's maybe try and read the type errors. Okay. On 26, 50, 53. That's just the one on the end there. We're expecting text. Contains. Okay, because we're calling them together. Those two things? That might be right. Yeah, that's what we're checking out here. Oh, yeah, I'm good. Let's go back to this bag. I want to put, so I use bags twice there. I want to put B there. Which means we need to handle that tuple that we get in bags from the map. I think we might be able to do that here, maybe? What do you think, GHC? Give me my typo, come on. There we go. Still not quite getting it to you. This is getting weird. I don't know what's going on with this. Okay, so what's a function of int? So that's pretty easy. We know what that function is. Should just be second. Takes care of that. Our map is upset with us. Of course, comes find numbags. Has to take a tree. So let's just flip it around. Along with our graph. Takes care of that. one is... This might just be maybe a precedence. Yeah. Okay, man. Dang, nabbit. Let's just set up bags. Ugh, 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 ugh. List a set of bags. How do I go about fixing that now? That means that we need another, like, is there, maybe we could use, or set like to list. Just transform that after we cons it. Let me Google that quickly. Hopefully that'll be enough. Google find that. No. What instances do we have on set? What do we have in set? Yeah, the set is foldable, that's nice. Equal each other, orderable. Oh, we have a monoid, that's good. Yeah, so we can mconcat them. Stick an mconcat on it. Doesn't like me tonight. Over here. I'm being silly. That's what I do. List of bags. We're getting a list of bags because I'm a dummy. If you're still around, Alice, feel free to pitch in. Let's see. The list. Set of bags. Doing something funky here. What's the type of map? This expression here. No, not the... Without good editor tooling, with good editor tooling, I'll be able to highlight this and be able to just see what the type of. Yeah. Right. Well, it's kind of telling me that anyway, I guess. a set of cons. The map is returning. Still, oh, the map is still returning a set of bags. Okay. And this is not a set. Bags. Okay. I mean, that kind of makes sense. So, how do we fix that? More hacks. Simpleton. Doesn't have it. Cat map. Oh no, what am I doing here? Okay. Messes something up, but I'm running out of time. That's gonna have to be it for tonight, folks. Erg. I hate leaving it like this. Let me just try one more time. Okay, let's just try from the hole. Okay, so our hole, happy daisy. We gotta do our recursive case. Bags. That is the list of contains. Okay, so the first thing we want to do with that is just get the list of bags. We'll do something else with it. So we saw that with second of bags, right? Stupid things work and a bit better. Okay. So we get just the from that. Let's do an let expression just for funsies. From that we get the list of bag names. Okay, bag name, which we can use to look up in our hash map for more bags to look in. Right. So when we open each bag, it's going to give us more bags to look in. So we want to collect those. Something. We want to do something with that. We want to map that over bags. And now the type of this going to be quite large. Weird. It's going to be a list of functions. Okay. All right, because of, as I remember from last, I'm just doing this. Can't just map this like that. You have to give it the graph. Okay. So now we have a list of set bags. And in this hole, we need to give it... Just peel it off on Lambda for now until we figure out what it is. Okay. Alright. So from here, what can we do? We have SS, just our list. A set a bag. We've used bag primes already. We've used bag tree. We haven't used B yet, which is just the bag that we have. So we need to use that. And we need to return a set. So let's construct a set. Just going to be extra paranoid and use extra parentheses. B with SS maybe? Would that be a thing, Haskell? Or sorry, S. Now we want to take the union of these things. So we don't want the whole set of all the elements that can be reached. Might be okay for now. What did I do here? Accidentally changed expectations here. That's not quite right. Yeah, valid hole fits are always funny. Okay, we could... well, we can use from list on the list of sets to get a set. But then that's a set of sets, and is Haskell's set smart enough to know what to do with it? Yeah, so we get a set of bags from that. Which is no good. But can we do unions from that? Oh, they'd have to be both sets of sets. I'm not quite there yet. Something I'm doing I know I need to use... Excuse me, I know I need the union the recursive call of SS with something. Jeez, what is it? Ugh. What if I move this over here? It's kind of what I wanted to do originally. What do I get? Okay, yeah, I get the set of bags again. Not feeling smart right now. Yeah, okay. I'm gonna have to throw in the towel stream. Oh, I'm falling behind on Advent now, but that's okay. So, anyways, eventually once I figure this out, the idea is that you just keep looking through the hash map recursively, pulling in more nodes, because this hash map basically implies the direction from the node to its descendants. It's kind of a one-way sort of thing, which is kind of like the trick of it. And Bob's your uncle. So thanks for tuning in. I'll see you probably next week. And if I'm still sticking with this advent of code by next week, maybe we'll be on a problem by then. It really depends on how far I fall behind, and whether I can catch up again. Otherwise, we'll probably end up getting back to the database, or maybe the text adventure game, depending on how I'm feeling. It's got that time of year I might want to work on the text adventure game just for a little bit, just for funsies, but we'll see. So, thanks again for tuning in. May your monads always be free and your types always check. Peace.